Let's continue curve sketching. Now consider this function. This function, the domain is all real numbers. Domains are very, very important things to consider. That determines where we are going to sketch the curve. Now, in the first derivative, well, I don't do the detail because I suppose you know how to find the derivatives. We differentiate and then we simplify. We get this is the first derivative. Now from this function, we know that the derivative is negative with x less than -1. At -1, the derivative is 0. And greater than -1, the derivative is positive. So this -1 is the maximum, right? Now, then we do the second derivative. Second derivative, we take a derivative and simplify. We get this, from which we can find that is negative less than 2. At -2 is 0. And x is greater than -2. The second derivative is positive. But also note, we pick up a special point at 0. At 0, y is 0. Why we need a particular point? That is important because once we have a curve, we have to nail the curve to our coordinate system. So that we have to find a particular point, so the curve can be positioned into our system of coordinates. Then also we consider that there's a horizontal asymptote. When x is approaching the negative infinitive, we take the limit. Well, I don't do the detail here, but I suppose you know how to find the limit of this. By L'Hopital's rule or whatsoever. So we get the limit when x approaches negative infinitive, y is approaching to 0 from below. So that is information. That information helps to sketch the curve. Now then we find a particular point when x equals -1, y is equal to -1 over e. When x is a -2, y is equal to -2 over e squared. So we have plotted the point. This point is here, right? This point is a -1. -1 at negative e, 1 over e. Okay, that is the point. At a -2, this is -1, this is -2, is a -2 over this point. This point is a -2 over e squared. So that is this point. This is the point. This is the point. The curve passing through. This is the asymptote. When x approaches a negative here, that is this is asymptote, right? Approaching to 0 from below. And what else? Yes, I think everything is okay. So the curve looked like this, then this, then this, right? Now let's check the derivative sign. When x is less than -2, second derivative positive. You see, positive. Now, second derivative. So, sorry, I point in long line here. When x is less than negative 2, the second derivative is a negative. Negative. Right? So the shape like this, you see? Decreasing like that. First derivative is negative. Negative. Negative first derivative. Negative second derivative. That's the shape. After negative 2, second derivative is positive. So positive. Positive. That's the shape. You see? That's the shape. After negative 2, see, look at the shape. Look at the shape. This is the shape of a curve. Second derivative is positive. And you can easily check that first derivative. Well, you know. So this is the curve obtained from the derivatives as well as the asymptote and the particular point. Okay, this is very nice example. Now let's consider this one. This one, the domain is this, right? All real numbers. We take a derivative. Suppose you know how to do derivatives by quotient rule, then simplify, you get this. From this, we can get the sign is positive or negative in each of the subintervals. So this one is the minimum. No, this one is a maximum, yeah, increasing, decreasing, right? Then the second derivative, the derivative of this one, you take a derivative, then you simplify, you get this one. Then from which we know that we can get the signs of second derivative in these intervals. And at 2 is 0. So this at 2, the function may have a point of inflection. Then we consider asymptote. When x is approaching the positive infinity, this function is approaching to 0 by using L'Hopital's rule, right? So this means that when x is positive, approaching to positive infinity, the function looks like this. Okay. And then we're looking for some specific point. When x equal to 1, put a 1 here, y equal to 1 over e. Okay, this is 1 over e. This is 1. This is 1 over e. Say this is 1 over e. So this is the point. This is the point, the function, the curve passing through. When x equals 2, y 2, because at 2 is point of inflection. 2 is here. And this 2 is 2 over e squared. So this is 2 over e squared. So this is the point passing through asymptote. Well, what else? What else? Vertical asymptote, right? When x is pushed to 0, no. Wait a minute. When x is 0, this y is 0. So this is the point, right? So before this point, function is increasing. So the function is increasing until 1, right? Until 1. Then reaches the maximum. then decreasing, then decreasing. Decreasing until x equal to 2 is a point inflection, then asymptote. Yeah, that is the curve. See? If we check carefully, okay, before 2, the second derivative is negative. Before this point, the function look like this. After 2, the second derivative is positive. Positive. So that's the shape. This is the shape. This is the shape. Okay. Let's do one more. This function. Now this function, x is not defined as 0. That means this function is defined everywhere but 0. Okay, now first derivative, use the quotient rule and simplify, you get this, from which we know that the first derivative is 0 at 1, and before 1 is negative, after 1 is positive. So at 1, the function is reaching maximum. Then the second derivative, well, take the derivative from this one, use the quotient rule, and simplify. Now then, we know that this is always positive. This is always positive. Why? Well, because this was equal to x minus 1 bracket square plus 1. It's always positive. So the positive negative depends on the denominator. When x is negative, it's negative. When x is positive, second derivative is positive. Now those results will give us the information to sketch the curve. And then what else? At 0 is not defined, right? When x is close to 0, then this goes to positive infinity. That's the asymptote, vertical asymptote. When x is approaching 0 from left, then this is negative. So this is negative. This will be asymptote negative, right? This is vertical asymptote. At 1 is a derivative, first derivative is 0. At 1, when x equal to 1, that's equal to e, right? Yeah, this is 1, this is e. So this is my minimum, decreasing, increasing. And what else? Well, seems everything there. When x approaches to negative infinity, it approaches to 0 from below. So things like this. This is this, this is this, this is like this. This is the minimum. So we can sketch the curve. Sketch the curve, right? So this is asymptote. And this is the asymptote. Reach this point. After 1 is increasing. Wow. What a beautiful curve. Now we can check easily. We can check easily that second derivative is negative before 0. See the curve? Negative. See? Negative. After second derivative is positive. After 0 is positive. See? It's positive. See, this is really nice. And I don't want to put too many examples in one episode, so that's enough for today's sketching. And I'll see you next time. And thank you for watching.